Welcome to implicit differentiation. All right, so example number 1, 4x plus 3y equals 7. So we can notice a difference from the previous examples or previous derivatives that we've been doing. They've all been y is equal to something. So now we've got a situation where the equation is not equal to y. So that kind of gives it away that it's implicit differentiation, or we can use this method to calculate the instantaneous slope. And so the first step is to, when we have a y in the equation, in this example we've got a 3y, we're going to do our derivative on any of the x's the same way we did before. But whenever we have a y, we're going to actually do a kind of derivative on the y, but we're going to add in an extra y prime whenever we do that. So you can see in step 2, the 4x, the derivative of 4x, that's exactly like what we're used to, plus the 3y. You can see in step 2, what's happening there is you're doing it just like you would the x, but the final step is to add an extra y prime there. And then, of course, the 7, there's an x to, we can imagine there's an x to 0 there, or a y to the 0. It doesn't really matter. But that ends up being 7 times 0 is 0, so that just drops off. So you can see we end up with 4 plus 3y prime equals 0. And now we want to solve for the y prime. And at this point, I'm going to tell you that y prime is equal to dy dx. So we've got a 3y prime equals minus 4, and now we've got y prime equals negative 4 over 3. And I've plotted the original function in Desmos so you can see what that graph looks like there. Okay, so continuing on with our first example, we've solved y prime is equal to negative 4 over 3. I've told you that y prime is equivalent to dy dx, but let's go ahead and see if we can prove that mathematically. So we're going to measure the slope. We can see that in Desmos that original equation is a straight line. And so we're going to go ahead and measure the slope on that line, delta y, delta x, and we get a delta y, delta x of negative 1.334. And if we change our y prime answer from negative 4/3 into a decimal, we see that we get a negative 1.333 repeating. And those are virtually identical. So we can see that y prime is in fact equal to dy dx, and we already knew that dy dx is equal to delta y delta x, which is equal to the slope of a line. All right, so here's example 2, and you can see we're doing the same thing where we've got our 2x, that's the derivative of the x squared, and then we're going to do essentially the derivative of the y squared, but we're going to add an extra y prime in there. And the same thing, you've got in the next section, the 4y, we've got 4 times 1 times the y prime. And the 1 was the 4 raised to the 0, or sorry, the y raised to the 0 power became that 1. And that's the calculus part, that's the implicit differentiation of that original function of example 2. And then all the rest is just algebra, and you can stop the video and go through the math. The one thing to point out here is when you have multiple y primes in the equation, you want to get all the y primes to the left side of the equation and everything else to the right side of the equal sign, and then factor out the y prime, and then that way you can get it by itself and then divide the rest over. All right, so here is example 3, and it's got something a little different in it that we need to point out. So we've got y to the 4th power minus 2y squared x squared plus 3x squared equals 0. So that middle term right there we're going to have to treat a little bit different, and if you You may or may not catch this, but you can see that that's two products, right? Two things multiplied together. So we're going to do the product rule for that section. So in the first y raised to the fourth power, we get 4y to the third power, and then we add our y prime, minus the derivative of the first times the second plus the derivative of the second times the first. That's what that bracketed part is. So you see that the 2y squared, we're going to take the derivative of that. That gives us 4y y prime times the original, which is the x squared. Then we're going to put a plus because this is the product rule. And then we're taking the derivative of the x part. So we've got 2x times the original 2y squared. So that's kind of the tricky part on that one. And then plus the derivative of 3x squared is 6x. Now, the other tricky part is sometimes people forget to distribute the negative all the way through. So in that step number 2, you can see the negative has been distributed all the way through. And the 2 times 2 has been combined on the second part of that section. Okay, and then all the rest is just the algebra. And you can see, stop the video or pause the video and look at that.